Cool. Let's start. Hi, everyone. Welcome to Genloop's Research Jam Session 6. Today, we'll be discussing the Qwen3 Technical Report. Just a quick word on Genloop. We are a company that helps enterprises build their domain intelligences seamlessly. And we do that in three simple steps. One is integrate with their enterprise data, power the entire LLM development cycle, and then integrate in a single line of code with their application so that they can really own their AI. Next, please. Qwen3 Technical Report, the paper we are discussing today, was highlighted by our LLM Research Hub, which is a pipeline, an AI agentic pipeline that sources the best papers and then ranks them by relevance, quality, popularity, and impact. Qwen3 was the top paper a couple of weeks back and has a lot of relevant details about how to train new models and how to build foundational models. And that is what is really interesting for us to follow. So hence we are covering it in this session. Next, please. And Research Jam is basically discussing the papers highlighted in our research hub. So this is a selective space to discuss GenAI research every other week. So you're welcome to join in the future ones as well. And thank you for joining in this one. Next, please.
Just 1 second. Yeah.
Yeah.
Okay.
And with that, over to Pooja to discuss the paper. Thanks, Pooja, for doing this.
No worries. So, hi everyone. I'm Pooja, and today we will be talking about the Qwen3 model, the architecture, and how the training was performed, and the different nuances that are associated with it. If at any point you have any questions, feel free to post in the chat. We will also have an interesting discussion towards the end. And yeah, so I hope you enjoy, and yeah, let's go ahead with it. So basically, if I have to give you a quick insight into what's new with Qwen3, the first thing is that it has a dual personality mode. What dual personality mode means that it can switch between thinking and non-thinking modes. I will also touch upon what it means to have thinking and non-thinking modes as well. Then the second thing is that there is a thinking budget that is associated with it. If there is a simple task, it will use less brain power. If it's a tough mathematical puzzle, then it will use more brain power. And the third very interesting thing is it can speak 119 languages. That just basically means that it has support for more languages as compared to the previous models and even the state-of-the-art models that are available right now. Okay, so there are 6 dense models that have been announced. So dense models are nothing but models in which all the neurons are activated at once. Then there are 2 mixture of experts models as well. And amongst these, Qwen3 235 billions A22B is the biggest and the smartest model. So yeah, let's quickly understand what changed in Qwen3 dense models as compared to Qwen 2.5. So there are definitely more layers. More layers allows us to essentially understand deeper sentence structures, not just something like in layer 1, maybe you can, maybe the model can understand that, okay, there is she, it's a pronoun, the parts of the sentence basically. Then on layer 6, it understands, oh, this is a conditional sentence. If this had happened, then this would have happened, right? And on the layer 20, because it had more layers, then it tries to understand, oh, the speaker is showing regret. So that's why more layers are definitely interesting in supporting complex thinking. So then there is something called group query attention that is also used. So I'm sure you all know what attention mechanisms are. So let's say there are 2 questions. Question 1 is what is Qwen3? And second question is what is MOE architecture? Now, how you and I will understand this question? Okay, so these both are questions that basically are prompting us to give the definition of Qwen3 and of MOE architecture. So normal attention model, what it will do is first it will go and process, okay, what is Qwen3? Oh, so basically my main word is Qwen3 and there is a question that is being asked. So in terms of Qwen3, Qwen3 will be my core token, talking about question 1 in particular. But when it comes to like the understanding in the context of what, then the model understands, okay, what is the main query word and Qwen3 is my subject. So now what group query attention does, it basically takes like a shared attention head. And what the shared attention head does, it understands, oh, question 1 and question 2 are very similar right now. So what is a definition starter? Then is, oh, it's a verb. Then it understands that the third word is the key term. So for question one, the key terms is Qwen3, and for question two, the key term is MOE. So it understands that, okay, this is a central word. Then if there is some next word, like in question two, there is architecture as well. So in question two, the details are added to the central word, right? And the last question mark is just a common closing. So having this GQA is particularly useful for FAQ style charts, wherein more questions are asked again and again. Then with this, less compute is used and gradients are also shared while training. So quickly understanding the activation function that is used for Qwen3, it's a swig loop. So I'm sure you understand the activation functions, what is ReLU, what is GELU. So here they have used swig loop technique to help decide which neurons to activate more. And it's a gated activation and contextual. There are two weights per neuron. So basically, Swiglu flips the signal, scales it, and then it becomes context aware. So then there is one final thing, which is the rotary positional embedding. So this basically enables the model to understand what word succeeded what. So transformers don't really have a concept of order. I mean, you have to make the model understand that when a dog is biting a man, it is not the same thing as a man biting a dog, right? So with rope, the word position is preserved. Like, for example, if you see here in this input, he was born in 1975. He moved to Canada in 1995. He returned in 2005. So, as humans, you and I understand that 1975, 1995, and 2005 are years that are in order, right? So, our model understands this by rote that through the sentence, it tries to get that 2005 is coming after 1995. So, it's sequential. And with this, what power does it model is that it will do much better in time-based reasoning and summarizing events in order. So in Qwen3 mixture of experts model, there's some very interesting things happening. The first is this fine-grained expert segmentation. Okay, so let's say there is an input, write a Python function to calculate the Fibonacci series recursively. Now just imagine that you've put 5, 6 people in the room. Let's say Ayush is an expert with Python, Aman is an expert with recursion, then Suz is an expert with general code support, and I am an expert with formatting and style. So what happens if you put the four of us in the same room and you say that write a Python function to calculate the Fibonacci series? We all will pool in our individual expertise and give out the best possible result, right? So with this fine-grained expert segmentation, it understands that, okay, I have to activate these particular experts and the output will not be off topic and bloated and the training becomes really efficient. So we would be able to produce a code that would be syntactically correct, optimized, logically recursive, and all of this is taken from the input. So in the input, the model sees Python function Fibonacci recursively. So for four experts it required, and it gave to the query to the right experts, right? So then we have fine-grained expert segmentation, but there are also no shared experts. So what do we mean by that? So let's say you have a sentence which is, I want to translate this into German. I would like a cup of coffee. Now, in English, you and I understand, I would like is a polite statement, and it is very common in our daily language. But the ideal German translation would be, excuse me, I do not know German, but let's say I try. So it says something like, Ich hatte gern ein Tass Kaffee. All right. So now this is polite in form. Somebody who is an expert in German would be able to understand this well, that this particular tonality, this particular sentence is polite and it is more formal. But let's say that in a certain model, there are two experts that are always active. One is an expert who is a general English to German translator, and five is an expert who's a generic language modeling filter. So when these two are always active, they will try to get involved in all of the tasks, even though it might not be in their domain or not, right? So what it will do is it will generate something like ish will kafi. Now it is grammatically correct, but it is rude considering in German this is something of a demanding context. Like you do not request your server like that, right? But when experts become dynamic based on the context, based on the tokens that are coming in, so what this will do is it would check the tokens, and then based on the tokens, it would activate the particular experts. So would be given to an expert, which is an expert in generating polite subjunctive output specifically for German, right? So you can also understand this in the sense that, let's say you have a friend who's really good at writing tweets. Okay. Now you have to send in a job application. So when you send in a job application, you just ask him, you're really good at writing. Can you please add a cover letter for me? Okay. And since that guy is really good in writing tweets, what if he ends, I mean, he would definitely end up writing, yo, bro, please hire me. All right. So he's not wrong. He did his task in what he was actually good at, in writing short length content, writing tweets. But the requirement of the user, the requirement of the person applying for the job was not that. Hence, the dynamic nature of experts makes the model better. Now, there is another thing, which is the global batch load balancing law. So you can just think of it like, let's say there are four experts, and this there is this one expert. So just to give you some context, an expert will be an expert in what is not defined. It keeps on rotating, and then based during runtime, the model starts learning what expert will do what task, right? So let's say there is this expert 42, and all the four models are using it. So by applying this global batch load balancing laws, what is happening now? It will start penalizing the model if it uses expert 42 again, because we want the optimum utilization of all the experts that we have, and we want diverse training. So what it does is it says that, hey, expert 42 has already been selected 3 times, slow down. So it will penalize if you use expert 42, but it will reward you if you use expert 91. So that's something very interesting that this batch load balancing loss is doing. Then for pre-training data, what the Qwen team did, they extracted knowledge from PDF-like documents. They
Just
used their own, yeah.
just one thing I wanted to highlight at this point was, so far all the foundational model techniques like Siglu or the MOE or the rope or the group query attention or even this balancing loss. This is nothing really innovative from the Qwen's team. So far, this
Mhm.
was something that was done by the Llama team or the Mistral team, and that has shown good results. So they have incorporated that. The really good stuff will start from now when they've taken interesting pre-training and post-training approaches, especially on the thinking budgets, the dual modalities of thinking, non-thinking, etc.
Yes, that's correct. So for pre-training data, so they use their own Qwen 2.5 VL model as the OCR model to extract from PDFs, and then Qwen 2.5 was used to actually clean and refine this text. So I think trillions of tokens were added. There were about 30 trillion tokens that were added here. And then they created synthetic data as well. So Qwen 2.5 math was used for math, question and answering, and then 2.5 coder was used for coding problems and solutions. Then for multilingual data, they added 119 languages, dialects, and not when I say languages, I don't just mean translations. They even added, different script styles and dialect understanding and code mixed inputs were also added here. So one interesting thing that they did, they also labeled and annotated every single instance of 30 trillion tokens. So they basically just made it a very balanced plate of training data, and they did not want to overfit it to any one particular domain. So let's understand how did they actually perform this pre-training and what were the stages that they took up. So the first stage was a general stage. Here they were basically trying to make the model gain world knowledge and become language fluent. So they started consuming, trillions of tokens of content. Then each sentence and paragraph was of 4,096 tokens. Then all of this was taught in 119 dialects, and now the model was able to understand grammar, basic facts, and knows how to talk like a human. So first stage is done. Next stage in the pre-training, now they have to make the model smarter. So now they started with reasoning tasks. So 5 trillion more tokens specifically focused on maths, programming, STEM, puzzles, all of this was added. Then again, 4,096 tokens were there for each sentence or paragraph. And then here, basically they taught the model to think. So if you can see on the screen that there's a question if x is 2 and y equal to x is 3, what's y? So these kind of questions were taken up in second stage. Then for third stage, they basically try to make the model's memory better to make it great for like agents, chatbots, document question answering. So they trained it on like super long text, and there was medium length text as well. And now here they increased the length of the sentence and paragraphs to 32,768 words. So for questions like summarize this 100-page PDF or answer on this entire chapter, all of this was learned in the third stage. Right. So they used very different benchmarks to compare with the open source state of art models. I've added it here. These are some benchmarks that you already must know. If you don't know it, then you can refer to these slides when we share it with you later. So talking about the evaluation, so their flagship model, it was inferred that the inference is cheaper and faster and beats almost every other open model. Then their largest dense model is very good on STEM and reasoning tasks. And the 14 billion parameters based models, it beats like Qwen 2.5 versions, and it even outperforms the Gemma 3 version. And it's particularly good for math tasks. Then there are 30 billion parameters, one where the active parameters are 3 billion. So this one is really good if you want an efficient and performant model. Then there are 8 billion parameter one. So it's like a small model, but it's very powerful. So it beats Llama 3, Qwen 2.5, and the other Qwen 2.5 on mathematics at different evaluation parameters. And it also has like a strong multilingual performance. So overall, like for the Qwen 3 models, they're really good at reasoning as well as in multilingual performance, as you'll see in the next evaluation metrics and in the post training as well. So again, the 4 billion parameter one is good at like 8 out of 15 tasks. It was the highest. And then if you want low latency and high accuracy, then you should prefer like 4 billion parameter one. Then an even small model, it's a very tiny model. So this would work well if you want to use it for edge or mobile related tasks. Then it does a lot better on general knowledge and multilingual understanding. Right. So these were like some metrics. So you can maybe look at it and have a better understanding from the paper or from the slides, wherever it is feasible for you. Then let's come to post training. So
Just
yeah. Mhm.
just to drive the point here, one of the very good offerings from the Qwen 3 series was smaller sized models that were outperforming a lot of their peers. So whether it be the 1.7, the 4, and the 8, and we have also done internal experiments with them, and we have seen very impressive results. We'll probably share them in a blog post, but their Qwen is somewhere slowly replacing the place that Llama held for a long time, uh, and is becoming the de facto model to go for when you want a smaller sized, a smaller form factor model with good reasoning and good understanding capabilities.
Yes. Yes. So now in post training, they had two major objectives. The first major objective that they had was to switch between the thinking and not thinking model. So what I mean by thinking and not thinking for people who don't know what that is. So when like let's say there is an input, what is the value of x in the equation 2x plus 3 is equal to 11? So in the thinking mode, the model will give an answer step by step. So it says that you can start by subtracting, then it shows the work that is done, and it's dividing, and then finally it gives an answer. Now the value is 4. In a non-thinking model, then the model does not do the step-by-step reasoning as into how it actually reached to the answer. It just outputted the to the point answer, which is x equal to 4. So the first objective is to do that. There should be thinking control. Then the second objective is to basically do distillation. Distillation is nothing but making a smaller model understand from a bigger model without actually training it again. So I'll explain this a little more in the upcoming slides. So yeah, so I have the slide again in one section. So I'll just talk about it there. So two main objectives. One is to switch between think and no think, and the other one is to do this strong to weak distillation. So in the post training, so the first stage is essentially log chain of thought thinking, cold start. So here basically they started to build like a hard question data set. So let's say one of the examples is I'm sure we've all done it in our high school mathematics. That what is the derivative of sine x to the power 2? And then here they also removed questions that were easy to answer. Like for example, what is 2 plus 2? So this is not a very suitable question for training reasoning based models. So they use their own QWQ 32 billion parameters one to generate these chain of thought style answers. And here the model was able to learn how to structure a solution, how to break down problems, and how to actually format reasoning. Right. So then moving on to the next stage. Here they did reasoning reinforcement learning. So let's say there is, they basically made the model train on very hard unseen queries, right? So there's a question: a farmer has cows and chickens. There are 22 heads and 56 legs. How many legs of each animal? A very common puzzle that we all have been doing, right? So now the model, what it does, it gives multiple step-by-step answers. And here there is reward-based ranking. So if there is a correct answer which you're using, you get a high reward. If you have wrong or repetitive steps, or if there is a skip or a stale logic, then you get low or no reward. So here GRPO is used, and it does encourage very good reasoning habits. So there is a balance between bringing new ideas, new answers, and exploitation, which is already using the things that the model has. So it keeps the entropy, the change that is there in the model, stable. So for this particular stage, they use like a new data set of about 4,000 queries. And in this stage with RL, the team actually saw a massive performance jump from about 70.1 to 85.1 AMI score. And they did it in just 170 steps without any manual hyperparameter tuning. So that was interesting. Then in the next
So
stage, yeah.
I just wanted to confirm that as stage two in part of RL, they just applied GRPO. So there weren't any other policy optimizations like DPO or VPO or anything like that.
No,
If the paper
yeah.
specified anything.
So not that I know of, but I'll still like check and confirm. I think it was GRPO that they used.
Oh, okay,
Yeah.
yeah, probably.
Yes. Cool. Moving on to the next step. So now here, the thinking model fusion, basically the duality that we were talking about, thinking and non-thinking. So they created like a new training set altogether, wherein thinking style samples of the chain of thought. So chain of thought is nothing but the step-by-step answering that the model is able to do. And then there were also non-thinking samples with to-the-point answers. So then chart templates were created. Chart templates, the one that you see in the red boxes. So stuff like this was created, wherein when there is a think flag, then the assistant should be answering within the think tags and then like supplying the answer. When there is a no think tag, then the model should not provide the answer between think tags and just like outputting the to the point answer. Okay. So after stage two, we saw that the model became really good at reasoning. Okay. But here, the reason why the need of this thinking model fusion arises is that do we actually need step by step analysis for all questions that are present in the world? So, in this stage, basically, the model understands that, okay, I have to think for these particular tasks and I don't have to think for another particular set of tasks. So, the model now becomes, now becomes able to handle both kinds based on the user input, whatever the user is providing. So, and it also does something like an intermediate thinking. So, let's say that you limited its thinking budget to 100 tokens. So, what it does is after 100 tokens, it will stop mid thinking, but it will still give you the best possible response. So, this is extremely beneficial since it does implicit thinking, and we don't need two separate models, a thinking one and non thinking one. And also, like I was talking about, the second objective of post training was to do distillation from strong to weak models. So this, while this stage three also gets inherited in that small model during distillation. So yeah, and the final stage was to essentially make the model understand how to behave like a great assistant. So instruction following, there must be like a lot of times wherein you ask any AI model that you're using that do not give any explanation, just give me my specific instructions and just give me the answer in that format. For example, give me 3 steps to bake a cake, do not explain. Then format matching is that when you want like JSON based output, Markdown based output, then there is preference alignment. Preference alignment is nothing but making it more human like. And agent ability is like is it able to use tools and APIs? Like for example, in ChatGPT, there is an option to search the web. So is it able to use that properly? And then there is RAG hallucination, which and here it basically checks that it is able to extract from the context without actually making things up. So Qwen3 here is using a multi-reward strategy. So first is like rule-based reward. Is it the structure is fine, the format is fine, is it accurate? Then there is model-based reward as well. What they do, is that they used Qwen 2.5 to compare the response versus the ground truth, and then they assign a score to it. And then there was preference-based reward, um, as in how aligned it is on human likes and dislike, how helpful it is, what is the tone, is it creative? So this multi-reward strategy is used to train the model at this stage. Then coming on to the strong to weak distillation pipeline. So this is done in two ways. One is the off-policy distillation, one is the on-policy distillation. So what off-policy distillation does, it basically shows it how the bigger model is able to think and how the bigger model is able to function in the no thinking mode. So, and then the model is able to learn how to, in thinking stage, how should it wrap between the think tags and how to compute derivation for this particular question. Like if I take an example here, what is the derivative of x squared? So it is able to understand how to compute the derivation, how to format and actually explain it. In the no think mode, then it is able to understand that, oh, I don't have to explain things here. And it tries to understand, okay, here I have to show full steps and here I don't have to show full steps. And then it, so when I say teacher, I mean the bigger model from which we are extracting the context, extracting the answers there. So it is able to basically go very similar to the bigger model's reasoning depth and tone here. So I think the reason why this particularly helps is because we don't need to basically ask small models to discover logic again from the scratch. So what they do is this is mimic smart responses and learn how to do the switching instantly, and it's faster and cheaper as well. Just how you are doing, when you study in school, when you study in the university, then you don't start to discover the subject from scratch. If you're learning physics, you don't start just trying to understand the laws of the nature by yourself. So you start mimicking the smart responses, what's there in your book, what's there, what your professor is teaching you, and then you understand how to build your own reasoning. Yeah. So in on policy distillation, the same thing is happening. Now the small model, the student is trying to generate responses on its own. So here you can understand it by this example that let's say that you were studying history as a subject, right? So you understood it that, okay, like if I have to write about Battle of Plassey, then I'll just, I understood it, what was written in the book. Then I made my own answer. And then I compared it with my teacher's notes. So it understands, oh, okay, maybe I could have written this particular sentence better, or I could have named XYZ. And the same thing is happening here in on policy distillation. So it attempts the answer, compares it with the bigger model's answer. The answer is the same, but the thinking process is different. So here it tries to become as close to the thinking process as possible. So it compares the logics and then it computes the KL divergence loss and understands how different are they, right? So here it also understands how much thinking budget it has to use and when to stop thinking. So that's also something that is there in the strong to weak distillation pipeline. Now, talking about the evaluation metrics that were there in post-training. So the Qwen3 235 billion, the one that the flagship one, it outperformed OpenAI and Grok with only 22 billion active parameters. So this one becomes state of the art in alignment, logic. When I say alignment, I mean preference alignment, the one that I was talking about, making it human-like, alignment, logic, and multilingual tasks as well. So then the non-thinking version, it does very well on general tasks, general knowledge tasks, and it beats Llama, Maverick, and GPT-4o math plus alignment. Then the Qwen3 32 billion parameters one, the thinking model is very good at multilingual and tool use. The tool use wherein search, APIs, etc. And it's the top choice for mid-size reasoning tasks. Then we have the 32 billion parameter non-thinking one. It does really well in multilingual tasks, and for its own weight, it becomes like the best-in-class model. Then for the 30 billion parameters one and the 14 billion parameters one. So the 3 billion one, it is it has only 3 billion activated parameters, but it matches like 14 billion plus in math and coding. So, and it's like the perfect balance of performance and compute efficiency. So then the 30 billion one in the non-thinking. So this is very good in creative writing and multilingual tasks. And even when we go into even smaller models, so it exceeds DeepSeek in logic and math. Then it outperforms a 14 billion parameter one in multilingual tasks and alignment. So it's like a very good choice with thinking capabilities. And then the non-thinking one, Llama 3.1, Qwen 2.5 base, and that beats easily. Then again, math, alignment, and multilingual methods. So again, overall, in multilingual and mathematical reasoning tasks, Qwen3 is performing super well. Then when we go to an even smaller model, again, multilingual and alignment is the best here. So then the smallest one that they have, so they have the best in class at 3 parameters in mathematical tasks, and it's the smallest non-thinking model with real world strength. So these were some evaluation metrics. Now there are some things that you all can discuss, some questions around it. So they saw that when in thinking, as compared to the thinking models, the non-thinking models were not very performant. Okay, so I have a few questions and we can discuss like one by one what could be the reason and what are your thoughts on it. So the first question I have is, what happens when we ask a model to think? Is it just longer text, or something deeper? If anybody wants to just like jump ahead and answer this question. So what do you think happens when we ask a model to think?
I think basically the whole point of trying to enforce it to think is that provide justifications for your answer, and just don't directly jump to final reporting of your answer. You should probably it's literally a step by step explanation. So
Mhm.
it's not probably a longer text. It is, yeah, it's probably going deeper into the question. So that is why even you take up proprietary models like DeepSeek or ChatGPT or anything. If you take up the reasoning traces, you see it actually tries to act like a human. It says,
Yeah.
I need to think along these lines. I need to think this, and then it has the aha moment when it tries to re-rectify itself. That way,
Mhm.
is this correct or not before finally answering the question. So it is very much kind of mimicking the human thinking process. It's not just longer text; it is just a better explanation as well.
Yes, that's absolutely correct. So yeah, does anybody want to add something to it?
Just adding to my experience, like I have this thought. So when we ask this, we think on it, and I want some ideas to get generated, maybe for
Mhm.
like interface or experience end. So it just not just answer me like typical model just answer you if you don't just just enter a query. But at that time, it also questions my like what all other questions you could have asked, what all other directions you could have explored. So that is the part when like I have observed when I specifically ask thinking mode in such mode.
Yes, yes,
Explore
very
more
true, very
direct.
true. Yeah. So the next question, I mean, building on top of that, so should we always allow the model to utilize its entire thinking budget, or is there a cost performance trade-off? What do you think?
It definitely takes
I
much
think
more time. So like of course at
Latency will
times
be an
I
issue,
just
yes.
directly want an answer or just go with I know the like I know what type of answer I want. At
Mhm.
those time I just want the answer. I don't want it to think a lot and spend time.
Makes sense, for sure.
you should kind of have like a robust router or something of those sorts that that doesn't map every query to a thinking model when a non-thinking variant can easily do the job or can get at performances, or in cases where deep thinking or reasoning isn't required. In
Mhm.
that case is probably. So yeah, even for enterprise cases or practical production cases, uh, latency is a very important factor that influences a lot of decisions in every step of the way in the pipeline, right? So
Mhm.
even if you're wanting to use a reasoning model or not a reasoning model, there should be an intelligent router that pretty much solves the task.
Yes, definitely makes sense. So for harder tasks, use the thinking model, and for trivial tasks like FAQs, etc., we should go for the non-thinking model. So, do you think that a model will be able to decide how much thinking is enough for it? And if it can, like, what do you think could be the path of it actually trying to do that?
I believe actually, so this is something that I witnessed personally, as trying to use DeepSeek for, this is specifically a DeepSeek thing. So trying
Mhm.
to use GPT for my exam preparations. So basically,
Okay.
there was this one incident where I just told this that I just gave it the background of how it would be helping me, that I have the space dynamics examination, and so I will be probably having a back and forth. So it actually had a thought process of close to 7 minutes, and I can't even fathom how much tokens that could be. So
Mhm.
I believe the R1. So this is 2 months ago.
Yeah.
It couldn't decide how much thinking it had to do. A simple okay would have been fine, and when I would have asked him or asked it the question, it could have
Yeah.
thought that way. But I just told him that you're my assistant for my space dynamics exam, and it basically
Mm.
started to revise and think of all the topics on its own before me actually giving it something. So
Yes.
I believe that was a pretty that was not so smart of the model there. So you actually have to decide how much thinking is enough, and this is where I believe distillation also helps. In some cases, this is just a follow up to the second question that suppose you want a model to have as a small reasoning trace, like you said, right?
Yes.
It always has to be between 500 or 700 tokens, or it
Mm.
strictly has to be less than 500 tokens. So upon distillation, you can retrieve just those reasoning thoughts, which are obviously one, high quality, but two, they have reasoning traces strictly less than 500. So doing this, the model will the smaller model or the student model, that will basically just
Mhm.
that, I am not allowed to go beyond 500 tokens, and
Mm.
basically I have a constrained I have a constrained token budget within which I need to
Mhm.
answer.
Yes. 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 Definitely. That does make sense. So, yeah. Does anybody have anything else to add on this?
I might not have a like technical thing that Ishan just said that these should be the limits, but
Yeah.
personally, what I feel is whenever I'm chatting with such models, I like to clear the expectation first that what do I want from you as a role.
Mm.
If I want a partner in my work, I do clear that. And when I want someone just like, for example, like an intern type person, just give me an answer, take my order and give me an answer. So when the
Yeah.
role is defined like that, okay, I need reasoning, I need a partner, not just a question and question answer kind of conversation. At that time,
Mhm.
I think it should think, but on other parts, if roles are defined like, okay, just give me an answer and we have a less time or constraint, then it's okay. You don't have to think much and you can optimize on speed at that time.
Yes. That's nice. That's nice.
I just wanted
I
to add
think
on
the,
top of this,
oh, mhm.
basically for sorry to interrupt you, Pooja, but I kind of
Mhm.
got an insight from the deep sea distill model of Qwen2. So this experiment was done at Genloop, during March, and we actually found out that basically the DeepSeek distills, when you taught it to the DeepSeek distill models, and you basically control the thinking parameters. So even with lesser thinking, we were able to get better results. But but once you applied GRPO, what happened is that the longer reasoning traces, as convergence was approaching, the completion
Mhm.
the completion length, basically the thinking budget, it started to decrease gradually. So the
Mhm.
qualitative interpretation of this is that with lesser thinking tokens, you were able to get better answers. Whereas the raw,
Wow.
non-fine-tuned or non-RL, non-GRP model, it used to take an haphazard number of thinking tokens with a
Mhm.
potentially incorrect answer as well. So yeah,
Mhm.
I believe overthinking can
One,
hurt model's performance in simple to moderate Q&A questions.
if I just
Yes.
add one intuition, so with more expertise, you know what to think and you are able to think quickly. And when you have lesser expertise, you have to think harder, you have to think of multiple scenarios and then come to a conclusion. It's similar to when a person is just entering a job, he has to think about multiple things, he's a bit confused and therefore has to think for a
Correct.
longer time. Plus,
Right.
when they
Mhm.
get experience, they're very direct in what they have to think and do. So it's the same thing as models build their expertise, their thinking token size decreases because they're able to think much more directly and precisely rather than having a long format thinking.
Yes.
Correct.
That.
And I believe that that's the reason that the mixture of experts model, they have a very controlled uh, reasoning trace. So, like I said, for other models which are not necessarily experts mixtures, they might overthink. But
Right.
the expert based model, yeah, exactly what your point was. It knows how much to think.
Right.
Great. Yes. So, The fifth one is like not a very technical question. It's like it's more on the side of how enterprises might utilize a model that has like a lot of tokens. So the previous slide that I showed, wherein the thinking models were performing best, were with 32K tokens, right? So and it did help and it increased the performance. So what use cases do you think that models with 64,000 token thinking budget, would be able to achieve? So this is just a non-thinking question. Just to give you an example, it could be like when you have to do understanding of legal documents, wherein you have to understand what the clauses are, and then try to generate summaries. So those huge documents, one use case could be used in the legal companies as well.
Apart from this, I think 64K token is a pretty much longer length, so you can actually resonate it
Yeah.
with the deep research functionality of perplexity or any proprietary models today. So they are basically agentic overflows, basically an LLM, which is a part of a major uh, agentic workflow. So that's the whole point of it. You kind of give it a bigger thinking budget, and you give it a like you said, domain specific, suppose a legal entity task
Mhm.
or even a financial domain task, something that requires, gathering and collation of a lot of information. So in that case, maybe 64K or around that token list would surely help. You know, so
Mhm.
basically, yeah, deep research kind of tasks. Those are the places where it would.
Yes, interesting. Anybody else thinking of any enterprise use cases?
I think it can also be used to like comprehend and refactor the large software repositories that we have.
Mhm.
To be able to like understand like different files and the interdependencies between them. That could also be done.
Yes, that is a very good use case as well. And enterprises today are involving a lot of AI products to actually solve that particular thing. So yeah, that's interesting. Cool. Then I'll move on to the next section. So, so now the Qwen team basically compared the effectiveness of on policy distillation, and they compared it with basically RL, and then using PAR 64 scores. So they found that the on policy distillation was performing better than RL, particularly for the 8 billion parameters Qwen model. So now just a few discussion pointers on this particular on policy distillation and its effectiveness, and linking it to RL as RL, etc. So yes, so these are the questions. So the first question is: if a small model mimics, like it tries to copy a big one's output, do you think it's actually reasoning or building its thoughts?
I'd like to add a research that Apple recently published. So it basically told that LLMs are copying monkeys type of thing. So if you gave them a really tougher question or something that was heavily out of syllabus, so to say for it, so it would then in that case it won't actually be related. It would just make up tokens. So Apple actually found out that it is not actually a genuine reasoning trace. It is just
Mhm.
kind of mimicking the data that it saw during distillation learning or RL.
Yeah.
So yeah, actually an open-ended question, to be honest.
Yeah. So it is an open-ended question for sure. Does anybody have any more thoughts?
Ishan, just one thing. This is the paper that that we just covered. That's what you're discussing, no?
Apple actually, I think it was Apple. I think it is Apple. Yeah, right. Correct. Correct. The recent user paper thoughts, right?
Got it. Did it say though that it is not reasoning? Like what I remember was it showed that it reasons to a certain level, and after that, on more complex questions, it just stops thinking. Like beyond its
Yeah,
capacity,
exactly.
it stops thinking. So, my intuition is a bit different on this. Like, I think if a small model is mimicking the reasoning or is learning from the reasoning of a bigger model, it does understand to reason, but it does not build the reasoning capabilities in itself. So there's a difference. Like it understands how to reason and maybe how to do some reasoning on
Correct.
tasks that are within its
Hmm.
reach. But for more complex tasks where it might fail or it might bound to it gets too complex for it to handle, it might just abandon the reasoning.
So effectively, it like basically understands the pattern here, and then when it again, like Ishant, when it goes out of syllabus, then it blows its top.
And
Yeah,
actually,
it
here's the thing.
understand
You
it.
actually, yeah, sorry,
Hmm.
Ayush, continue. So I think
I
Ayush is
think
on
you
mute.
want to mute. Yeah.
But actually, what they covered in the paper and also what is present in our as one of our points in our paper thoughts as well is that even if you provide it with a tougher or a complex question and you
Hmm.
give it kind of hints or basically a step-by-step explanation as to how the model should approach it, even in that cases, it shows no performance no performance improvement. Even in those
Hmm.
cases, it continues to overthink and potentially lead to
Hmm.
a longer a wrong decision. And this is observed in simpler puzzles as well. So yeah,
Okay.
even simpler puzzles, but out of syllabus or something that it hasn't seen before,
Hmm.
you cannot actually apply the reasoning pattern that you've learned in the training process to this
Hmm.
out of syllabus question, and that is you practically fall into a wrong trajectory.
Hmm. Yes, makes sense. Cool.
Actually, that
I
is
think.
the reason.
One more.
Yeah,
Hmm.
yeah. Sorry.
Go on, go on.
No, no, go ahead, go ahead.
Okay, my chain of thought on this would be like, let's say you have a smaller model. So I am guessing a smaller model would have a lesser amount of knowledge of things. So
Hmm.
let's say a model has like 64,000 ideas that it can think of, right? So if you train it from a bigger model and it has now like more ideas or like attention, things to give attention to, it cannot store them inside itself. So it
Hmm.
would start replacing the old things that it learned, or it cannot learn new ideas. So then it would, that is where it will reach its peak performance, I guess.
So essentially, like if we fine tune the smaller models, right? If we give it the domain knowledge, then it would enhance the performance. That's what you're saying effectively.
No,
Something
so
around that.
okay. Uh, okay, so basically, what my understanding would be, if there is a certain model, you train it, it
Yeah.
uh, assigns certain weights to certain ID concepts, right?
Fair.
And then when you pass it a query, it will match the query with those ideas that it has. So a smaller model would have a smaller amount of ideas that can be tuned, versus a larger model would have more ideas. So let's say food. If you have a very small model, it would categorize all food as food. There is
Yeah.
no junk or healthy food. But in a
Hmm.
larger model, you would have food, then you would have two categories under it, then you have 100 categories under it. So if
Hmm.
you try to feed those 100 categories, the smaller model would always assign all of those categories to food. So it would not be able to learn the specific subcategories of food.
Got it. Okay. Hmm.
Yeah, that is true.
Yeah.
It's basically saying the same thing that, suppose you try to find an 8 billion model. So the oracle performance, the oracle knowledge that probably an 8 billion model can have, if you try to still distill more knowledge from, say deep sea carbon, which is 670 billion model. So that is like that is equivalent to saying that, you're probably overloading the memory of a junior grade student with calculus or something like that. So yeah, it is bound to fail. So even if it knows
I
calculus,
think a
if,
better analogy of that would be like you're trying to, you have a 1 TB hard disk and you want to store all of its data on a 1 GB pen drive.
Yeah.
You
yeah,
can in no
exactly.
way compress that
Mhm.
data to store it there.
Yeah, exactly.
Yes. Interesting. So, I think instead of the second question, I would like to ask the third one because I find it very interesting. So, would you actually trust a model that learned by itself, that it did reinforcement learning, or it actually learned from a bigger model? It is a distant model. So, which one would you prefer?
From my personal experience, to be honest, if we're able to provide a distillation data set for the smaller model, that 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 is curated in the perfect possible way, even a particular domain, if it is able to, cover all the aspects of that domain and not sticking on a particular reasoning race, in that
Mhm.
case, in that case, probably Apple's research can be disproved.
Mhm.
Basically, if you try to provide a data set that is good enough, that instead of copying the reasoning patterns, it actually learns the underlying thinking process. Basically, you try to remove all the patterns out of it, and you actually encourage it to think. So in
Yeah.
that case, distillation would help. And actually, distillation followed by a reinforcement learning algorithm like GRPO or DPO or PPO,
Mhm.
uh,
Yeah.
something like that, that will surely help to gain a better performance. So it is A and B, not just A versus B.
Yes, makes sense. I was actually kind of looking towards going in this direction only, wherein we combine both of these things. So do you think like in future all these small models so like how Qwen did it, right? They distilled it and they found better results with it. So do you think in future all small models would go towards distillation and they will not go towards R? So what do you think? Will it be like a mixture of A and B again here, or will it go in one particular direction?
I mean, it is always a mixture of A and B. So it wouldn't always normally rely on just distillation process. So, consider just consider a base model, Qwen3 base model that has no thinking capabilities, and you try to distill it with reasoning traces from Qwen 235, the which has the reasoning mode activated. So you
Yeah.
basically fine tune a base model with reasoning traces. So initially it will learn that, right, between these two tokens I should think, and these are the reasoning patterns, these are the common reasoning analogies that I should try to follow. And post
Mhm.
that, you can actually throw it in the reinforcement learning space when it can actually improve based on its current mistakes, or GRPO, when it can optimize its performance based to its peers as well. So
Mm.
actually,
Right.
many models are doing that, and that is the reason, Qwen 2.5 32 billion was better than Qwen 2 72 billion, and similarly Qwen 3 14 billion is better than Qwen 2.5 32 billion, and also Qwen 2 72 billion, which is a reduction of,
Mm.
almost five
Yes.
to six times in parameter size, but still equal or better performance. So yeah, definitely that is the way to go.
Interesting. Perfect. So these are the questions that I had. When you refer to this presentation, I've added also some like little answers that you can refer to in case you were not able to capture it fully right now. I'll also add the points that were discussed here in the slides, so you can refer to those as well. Now moving on to closing notes by Ayush. So over to you.
Perfect. Thanks, Pooja. Thank you, everyone, for this engaging discussion. If you have any other questions, please feel free to reach out to us on our email. I've also added my contact number here. But looking forward to discussing the next session with you, and hope you all liked it. If you have any feedbacks, feel free to share them with us. And thanks, Pooja, once again. Thanks, everyone, for this engaging discussion.
Thank you
Thanks
so
for the
much,
session, Pooja.
everyone.
Cool.
Thank
Thank you, everyone.
Have a very good night.